ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಬೆಳೆಯುವ ಸಿರಿ ಮೊಳಕೆಯಲ್ಲಿ ಅಂತ ಹೇಳುವುದು ಹಿರಿಯರ ಅನುಭವದ ಮಾತು. ಜಗತ್ತಿನ ಮಹಾ ಸಾಧಕರ ಬಾಲ್ಯ ಬಹಳ ಕುತೂಹಲಭರಿತವಾಗಿರುತ್ತದೆ. ನಮ್ಮ ಭಾರತದ ಸಂವಿಧಾನ ಶಿಲ್ಪಿ ಡಾಕ್ಟರ್ ಬಾಬಾ ಸಾಹೇಬ್ ಅಂಬೇಡ್ಕರ್ ತಮ್ಮ ಬಾಲ್ಯದಲ್ಲಿ ಜ್ಞಾನಾರ್ಜನೆಗಾಗಿ ನಡೆಸಿದ ಹೋರಾಟ, ತೋರಿದ ಛಲ, ಹವಣಿಸಿದ ರೀತಿ ಇದಕ್ಕೊಂದು ಉತ್ತಮ ನಿದರ್ಶನ. ಯಾವುದೇ ಕ್ಷೇತ್ರದ ಸಾಧಕರ ಜೀವನಗಾಥೆಯನ್ನು ನೋಡಿದರೂ ಕೂಡ ಅವರ ಸಾಧನೆಯ ಬೇರು ಅವರ ಬಾಲ್ಯದಲ್ಲಿಯೇ ಬಲವಾಗಿರುತ್ತದೆ. ಎಳವೆಯಿಂದಲೇ ಬೆಳೆದು ಬಂದ ಸೃಜನಶೀಲತೆ ಮುಂದೆ ಸಾಧನೆಗೆ ನಾಂದಿಯಾಗುತ್ತದೆ. ಇದಕ್ಕೆ ಇನ್ನೊಂದು ನಿದರ್ಶನವೆಂದರೆ ಅಮೆರಿಕದ ವಿಜ್ಞಾನಿಯಾದ ಚಾರ್ಲ್ಸ್ ಎಫ್ ಬ್ರಷ್ ಅವರು ತಮ್ಮ 12ನೇ ವಯಸ್ಸಿನಲ್ಲಿಯೇ ಸ್ಟ್ಯಾಟಿಕ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯ ಬಗ್ಗೆ ಅನೇಕ ಪ್ರಯೋಗಗಳನ್ನು ಮಾಡುತ್ತಿದ್ದರಂತೆ. ಈ ಕುತೂಹಲವೇ ಮುಂದೆ ಅವರು ಹೊಸ ಮಾದರಿಯ ಜನರೇಟರ್ ಅನ್ನು ಸೃಷ್ಟಿಸಲು ಕಾರಣವಾಯಿತು. ಆದ್ದರಿಂದ ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನೀವು ಕೂಡ ಚಿಕ್ಕಂದಿನಿಂದಲೇ ಬೆಳೆಸಿಕೊಂಡ ಉತ್ತಮ ಹವ್ಯಾಸಗಳು ನಿಮ್ಮನ್ನು ಅದ್ಭುತ ಸಾಧನೆಯ ಕಡೆಗೆ ಕೊಂಡೊಯ್ಯುತ್ತದೆ. ನಿಮ್ಮ ಉತ್ತಮ ಚಿಂತನೆಗಳು, ಹವ್ಯಾಸಗಳು ಭವಿಷ್ಯದ ನಿಮ್ಮ ಸಾಧನೆಗಳಿಗೆ ಒಂದು ಉತ್ತಮ ಪ್ರೇರಣೆ ಆಗಲಿ ಅಂತ ಹಾರೈಸುತ್ತಾ ನಾವು ಇಂದಿನ ತರಗತಿಯನ್ನು ಆರಂಭಿಸೋಣ. Welcome to DC Machines and Alternators class. This is the one of the course in 3rd semester of Electrical and Electronics Engineering. Under this subject, we already studied under Unit 1, construction of DC generators, different parts, functions of each part, and working principle of DC generators, different type of armature winding, lap winding, wave windings, EMF induced, different types of DC generators, separately excited DC generator, self-excited DC generator, shunt generator, series generator, long shunt compound generator, short shunt compound generator, differentially compound generator, cumulatively compound generators. All those things studied under Unit 1. Also under Unit 2, armature reaction, effect of armature reaction, interpole, compensating winding, all those things we already studied. Now, in this class, our topic is commutation. Commutation is one of the very interesting and important topic in DC generators. We already studied one of the important part, commutator. Commutator is used to convert AC generated voltage in the armature conductors to DC for external load. ಯಾಕಂದ್ರೆ DC ಜನರೇಟರ್ ಆದರೂ ಆರ್ಮೇಚರ್ ಅಲ್ಲಿ ಜನರೇಟ್ ಆಗೋ ವೋಲ್ಟೇಜು AC ಆಗಿರ್ತದೆ. ಓನ್ಲಿ ಇನ್ ದಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಇಟ್ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು DC by using commutator. Armature conductor, EMF induced in the armature conductor is changes its direction when it is under north pole. Current direction is one side, while moving under south pole its current direction is reversed according to the Fleming's right hand rule. So this alternating current converted into direct current using the split rings or commutators in DC generator. The process by which current in the short circuited coil is reversed while it crosses the magnetic neutral axis is called commutation. See, direction of induced EMF is reversing continuously. The process by which current in the short circuited coil is reversed. This process is called commutation. The brief period during which coil remains short circuited is known as commutation period, TC. Here we can see the different parts of DC machine. Armature, this one outermost part, stator core, stator pole, stator winding. Similarly, rotor, armature, core, armature winding, end point of armature winding connected to the commutator segments. All these things, commutator segment. This is a brush. It helps to collect the induced EMF from the commutator to the external circuit. Next, central shaft. In this diagram also you can see north and south pole. This is the commutator segment. Commutator segment, brushes. Centrally armature, rotating conductors. According to Faraday's laws of electromagnetic induction, if conductor cuts the flux, an EMF is induced in this conductor. According to Fleming's right-hand rule, you can find out the direction of induced EMF. If this coil is under the north pole, induced EMF direction is one direction. If this coil is under south pole, induced EMF direction is another direction. But in the external circuit, current remains in the same direction because of this split ring. You can see the actual machine also here. This stator part, stator core, stator winding, pole shoes helps to spread the flux. Similarly, rotor core, armature, rotor slots, rotor winding, armature winding connected to the commutator segment. EMF induced from the armature passes to the commutator, then to the brushes, then to the external circuit. Centrally shaft. See, during collection of EMF, some spark occurs between the friction between this commutator and brushes. This also one of the problems. You have to avoid that or decrease that sparks. In this diagram, you can see that how spark is generated between the commutator and brush. This is the brush, this is commutator, rotating commutator. I will play this videos, watch. See here sparks, electric spark coming, both here and here also. So this spoils our brushes and commutator and other parts inside the DC machines. We have to overcome this problem also. Next, in this diagram, you can see the symbolic representation of the different parts, north and south pole of stator or field winding, commutator segment, brushes connected to the external load, and armature winding. Here you can see different type of winding, armature, lap winding, wave winding, we already discussed. This winding coil endpoint connected to commutator segments. These brushes collect the current from the commutator segment. You have to place this brush always in the magnetic neutral axis, not in the geometric neutral axis. Magnetic neutral axis is a point where EMF induced in the conductor is zero. That means moment of the conductor is parallel to the flux. No rate of change of flux at that moment. So EMF induced is zero. So current direction changing taking place at that point. If you develop that diagram, you will get the different diagram here. I will explain this also. Consider only this figure. This is the armature winding. This is the commutator segment. This is the brush. This armature setup, rotor is rotating left to right. So see here, this brushes fully contact with the commutator segment B. Different coil terminologies A, B, C, capital A, B, C. Commutator segment small a, B, C. Here A and B coil comes under one pole, C coil another pole. So EMF induced direction we can see under C, current flowing through coil C is right to left, current flowing through A and B is left to right. So total current comes to this B commutator segment 20 amps, totally 40 amps passes to the brush. Similarly, if rotor rotates left to right, what happens? We will study. This totally process is called commutation. So in this coil A and B belongs to one pole group and C belongs to another pole group, and the output of the brush is totally 40 amps. In the next, after some rotation, some part of the commutator segment A comes in contact with the brush. So some current from the coil A passes to this commutator segment A, then to the brush. So out of 20 amps, 10 amps takes this path. Remaining 10 amps passes to the armature coil B, then to the B commutator segment B, 10 amps. Another 20 amps from the C coil C to the commutator segment B. So here 30. Totally 40 amps enters into the brush. See here, previously current flowing through the coil B 20 amps left to right. Now it is decreased to 10 amps. So coil B undergoes commutation and the brush just makes a small contact with segment A, and due to variation in contact resistance, segment A carries 10 amps and B carries 30 amps, and current through coil B reduces to 10 amps. Here the armature is rotated some more. So more part of the brush comes in contact with the commutator segment A. So 20 amps of from the coil A passes to the A directly. 20 amps from the coil C passes to the brush through commutator segment B. So now no current through the coil B. This is now in magnetic neutral axis. Moment of the conductor is parallel to the flux. So no EMF induced in this coil now. It is the middle of the commutation where brush makes equal contact with the segment A and B. Therefore, current through coil B become 0, indicate the coil B is completely short circuited by brush. So both the end of this coil B is short circuited here, so no current. In the next diagram, coil B now belongs to coil C group. That means after some more degree of rotation, this coil B is comes under coil C group now. So current induced direction is changed from left to right to right to left. Hence carries current in opposite direction, and segment B carries 10 amps and segment A carries 30 amps as shown in the figure. So here 20 amps from the coil A, 10 amps from the coil B, totally 30 amps passed to the brushes through commutator segment A. So only 10 amps from the coil C passes to the brush through commutator segment B. Next important stage. Here full brush now comes in contact with the commutator segment A. It is the end of the commutation. Due to reactance voltage, current in the coil B may not be able to reach its maximum value, that is minus 20 amps. Hence, the rest of 5 amps complete its path from segment B to brush in the form of spark, result in bad commutation. Here, 20 amps from the coil A as usual comes to the brush through commutator segment A. Full brush comes in contact with the commutator segment. Width of this brush is assumed same as the width of the one commutator segment. So, but here current from the coil C not fully passes through the coil B. Only 15 amps flows through this. Why? Because coil has some inductance similar to resistance in the resistor. Resistor opposes the flow of current. Similarly, here inductance opposes the change in current. Earlier, current through this coil B is plus 20 amps left to right. Afterwards, it is decreased to 0. Now, current increased from 0 to minus side. That means current direction is reversed. 10 amps, now 15 amps minus. But it is not fully increased to 20 amps even though the brush shifted to the next commutator segment. This is because of opposition by this reactance voltage, opposition by the inductance. This inductance opposes the change in current. So remaining this 5 amps current jumps to the brush from the commutator segment B. So spark occurs. This is called bad commutation or delay commutation. Sparking occurs between the commutator segment and the brush. Reason for that is see jump in the current from the commutator segment to the brush in the air. This is marked here. So this variation of current with respect to time is plotted as shown in the figure. Here line AB here indicates current through the coil B before the commutation, and CD current in the coil after the commutation. This B to C represents ideal commutation, whereas this BK, this dashed line, represents bad commutation or delayed commutation or nonlinear commutation. The dotted line KC represents current completes its path as spark here, 5 amps current. This is due to the delay in the commutation. So in the ideal commutation, this path B to C is a straight line, but in the real it takes this non-linear path. So only 15 amps current flows to the coil B, remaining 5 amps remains that leads to a spark. The period, commutation period TC can be defined as the time elapsed between the instant the brush is fully under one segment to the instant the brush is fully under the adjacent segment in the direction of rotation from here to here. Time taken for this is called commutation period. Current in the armature coil changes its direction from positive to negative. Time taken is commutation period, TC. Reactance voltage. Each armature coil possesses appreciable amount of inductance property. This property opposes varying current through the coil by producing a self-induced EMF called reactance voltage. The production of self-induced EMF in a coil during the period of commutation is called reactance voltage. We already discussed. Coil consists of inductance in henries. Due to this, induced EMF is called reactance voltage. It opposes the change in current. Value of reactance voltage is calculated like this. Reactance voltage equal to coefficient of self-inductance L into rate of change of current. For example, if I is the current through the conductor, total change in the current during commutation is I change to minus I. In our example, 20 amps change to minus 20 amps. So totally change is plus 20 to minus 20. Totally 40 amps change in current is 40 amps. So in this example here, plus I to minus I, totally 2I. TCC constant period reactance voltage. So reactance voltage equal to L into 2A by TC. That means inductance into rate of change of current. If the commutator is linear, where change from I to minus I is linear, this is the equation. If commutation is non-linear or sinusoidal, then reactance voltage equal to 1.11 into L into 2A by TC, where 1.11 is the form factor. So we studied about the commutation in case of DC generator. Next, we will see some multiple choice questions on this topic. First one, commutation is delayed due to 4 options A, B, C, D. One is leakage reactance, B, effect of armature reaction, C, leakage reactance and armature reaction, D, because of other factors. Out of this, you have to select the more suitable answers. If A is the right answer, don't simply select the A. Go through all options A, B, C, D. Then only think and analyze which is the more suitable answer. Next, second question. Armature coil is short circuited by brushes when it lies. Option A, along neutral axis. Option B, along field axis. Option C, in any of the above position. Option D, in none of the above position. Here also carefully read the question and options and select the correct answer. Third question. In DC generators, current to the external circuit from armature is given through. Options are A, commutator, B, solid connection, C, slip rings, D, none of the above. So choose the correct answers. Question number 4. The commutation process in DC generator basically involves options A, passage of current from moving armature to a stationary load. B. Reversal of current in an armature coil as it crosses MNA. Option C. Conversion of AC to DC. Option C. Suppression of reactance voltage. So try to understand the question and all the four options and choose the correct answer. Fifth question. In DC generators, brushes are always placed along options. Options are A. GNA, geometrical neutral axis. B. MNA, magnetic neutral axis. C. Bisector of GNA and MNA. D. There is no rule. So select the correct answer. Simple one, this one. Next, sixth question. EMF induced in the armature of DC generator is. Options are A. DC, B. AC, C. AC and DC, D. None of the above. So usually DC generator is the question. EMF induced in the DC generator. So think, don't simply write. So DC generator, don't simply write the DC. So think and select the correct answer. Next, seventh question. Function of commutator in DC generator is similar to options A. Amplifier, B. Filter, C. Rectifier, D. Transformer. The commutator performs amplifier function or filter function or rectifier function or transformer functions. You have to decide and select. Eighth question. In DC generators, the brushes on the commutator remain in contact with conductors. Which options are A. Lie under south pole, B. Lie under north pole, C. Lie under intrapolar region, D. are farthest from the poles. So select the correct one. Ninth question. Which of the following components of a DC generator plays vital role for providing direct current of DC generator? Options are A. Dummy coil, B. Commutator, C. eye bolt, D. Equalizer rings. So this theory you studied helps to find out the correct answer for this question. Next, multiple choice question. The internal voltage of DC shunt generator drops on load because of all of the following reasons except. Options are A. Armature reaction, B. Armature resistance drop, C. Field weakening due to armature reaction, and armature decommutation. So here carefully understand the question, then go through the options and select the correct answers. See, multiple choice questions helps to revise or understand our theory studied in our class. So during this class we studied commutation process in DC generator and reactance voltage, all those things. Once again, go through this topic. In the next class, we will discuss about how to improve this commutation in DC generators. Different methods of improving commutations in DC generators. Thank you all.